Okay, so let's talk a little bit about analyzing polar functions. Right? Polar function, I just mean r of theta. So something like 4 minus 3 sine theta. So let's talk about maxima. Let's talk about solutions. Let's talk about zeros. Yeah, I think that's probably a good range of things to cover. So first of all, in terms of well, first of all, let's look at a picture. So we said r equals 4 minus 3 sine theta. Okay, so kind of similar to what we were looking at before. In terms of maxima, it's a little hard to tell from here. But you can see, just going to try to, obviously this is not as long as this, it's not as long as this, it's not as long as this, not as long as this, it's not as long as this. This is the maximum. This is the place where we're talking about the maximal distance from the origin. And so, in other words, when is R biggest? Now, most of the time that can just come from kind of analyzing this and saying, well, if I want R to be biggest, then I want to add 3. Why add 3? Well, remember that sine has an output of anywhere from -1 to 1. So if I want to increase from 4, then I want to have sine be a negative value because I want to change this from -3 to plus. And the biggest value I'm going to get out of it is -1. So when does sine theta equal -1? That's the critical question. And as we think about the unit circle, we know that that happens at 3 pi halves. So we should be able to find the maximum then at a equals 3 pi halves. And then R would be equal to 7. Clear off my drawings here and see if that's true. Oh, what happened to my sliders? 3 pi halves. Need to find R and replace, try to link so the definitions are. Yeah. Oh, I might not like the fact that this is, let's do E cosine theta, B sine theta, add slider for B, B is 7. There it is. There it is. There's my maximum down here. Okay. So the long and the short of it is that in terms of maxima, you got to kind of think about the shape that you're looking at and think about when sine or cosine is going to give you the value that you want in order for the maximal possibility to come out. Let me just do one more before we move on to something else. How about R equals 3 plus 2 plus 4 sine 3 theta. Okay. So this is a pretty crazy guy. Got an inner loop, got an outer loop. But again, when does it hit a maximum? Well, it's going to hit a maximum when sine is giving you an output of 1. And again, the maximum is going to be at 7. So if we said R equals 7 here, we would be hitting the maximum 3 different times. So here's one, here's another one, and here's another one. So a little more work to do here to find where we get our maximum, but I would start with R equals 7, and then you can work backwards from there. So let's shift back to the whiteboard. R equals 3 plus 4 sine 3 theta. 7 equals 3 plus 4 sine 3 theta. Minus 3. So 4 equals 4 sine 3 theta. So 1 equals sine 3 theta. So when does sine equal 1? At pi half. So 3 theta equals pi halves. And this happens, if we wanted to do the infinite solutions, we could add on 2 pi n, because then when we divide by 3, we're going to get our full set of solutions. We get it at pi 6, but we also get it every 2/3 pi n from there. So we should get it at pi 6, then we get it at pi 6 plus 2 pi thirds, pi 6 plus 4 pi thirds, et cetera, et cetera. So depending on how many maxima we want to produce, because remember that this is, let's go back, let's change this guy. 3 plus 4 sine 3 theta. Okay, pretty crazy. So as we go through this, right, we just hit a maxima there. That was at pi 6. And we're back in these little guys. Then we're back out to this guy. That's the next one. That's happening at, looks like pi 4ths. T equals 0.52. Oh, maybe that's pi 6 actually. Oh, because right, because we started the negative side. Sorry. Okay, so this is the first one, pi 6. Boom. Then we come out here. This is happening at 2 pi thirds plus pi 6. That's 5 pi 6. Okay, so then the next one happens there. And that's 3 pi halves. And then we get more as we go around. So remember, there's an infinite number of places where that's going to happen. Okay, so let's go back to our, oh no, I was sharing that the whole time when I switched over. Yeah, so let me just show that again. Pi 6, there's another one, 5 pi 6, there's another one at 3 pi halves. Yeah. Okay. All right, so that's maxima. We don't do minima because the minima is the 0, right? I mean, the minimum distance that R could have is 0, because even if it's a negative value, it just comes out the other side. So let's look at our zeros real quick. Take this equation. Zeros would be 0 equals 4 minus 3 sine theta, minus 4 minus 4, minus 4 is minus 3 sine theta. So minus 4 over minus 3 equals sine theta. So when does sine theta equal 4/3? Well, you can put it in your calculator using arcsine, but we already actually know from looking at the picture that that doesn't happen. Go back to this guy, right? It never hits 0. So this would be a no solution type of situation, right? There are no zeros to that. Now in this one, there are lots of times when it hits 0. And so then we would have to do some work there. And these answers are not going to be nice answers. And typically I would expect that, well, you should expect to be able to do both things, but it is nice when you have values that come out as your zeros come out as some recognizable theta values. So if I change this to 3 minus 3 sine theta, that would probably work. Yeah, so then I actually have a value where I get to 0. And it's a nice theta value, not some kind of random radian number. So solutions can come in two forms. That was the last thing that I noted here. It could just be asking for general solutions, which means I want you to tell me some pairs of numbers or theta values that make this true. Right? So for instance, in that case, I would choose theta values and stick them in. Like what happens when I put in pi halves? What happens when I put in pi thirds? What happens when I put in pi fourths? Just do the math, crunch it out. This really ought to be a no calculator question. You should be able to do this using your knowledge of the unit circle. Sine of pi halves is 1. 4 minus 3 times 1 is 1. Let's look at pi thirds. 4 minus 3 sine pi thirds. So pi thirds, sine of pi thirds is root 3 over 2. So 4 minus 3 times the square root of 3 over 2. This does not turn out very nice, so I'm going to make a common denominator, 3 root 3 over 2. So this is 8 minus 3 root 3 over 2. Then pi fourths, 4 minus 3 sine fourths, 4 minus 3 root 2 over 2. So again, 8 minus 3 root 2. So that's the basic idea of finding general solutions, right? And when you write these as coordinates, you just have to remember that the order is switched. You can say it as r theta, not theta r. But you might also have something like, let's find out when r theta equals, or when these two functions intersect. We could get pretty crazy here, but let's restrain ourselves. So again, starting with a graphical representation of that question. So I got this guy, and I want to know when it intersects with r equals 2. Let's take a look. Okay, so it looks like visually I've got 2 points of intersection here. And it doesn't necessarily look like they're going to be nice, so we'll just have to deal with that and follow it where it takes us. So first thing I would do is just to put the 2 equations together. So we've got 2 equals 4 minus 3 sine theta, right? Because we had r equals 2, we just stuck that into here onto this side. So now we do the math, minus 4 minus 2 equals minus 3 sine theta divided by minus 3. So this is 2/3 equals sine theta. So where does sine theta equal 2/3? That's going to happen twice. Again, I'm thinking about my unit circle here. It's going to happen here, but it's also going to happen here. So I use inverse sine. That gives me my first solution, which is theta equals 0.73. And then I can find my second theta using pi minus that. So I got 2.41. And so now let's go back and just look and see that that makes sense. So this should be the points 2 and 0.73, and also 2 and 2.41. So let's put in the numbers that we had here. So we're going to take B down to 2. That's our R value. And then this, we don't have a nice pi value for, so we're just going to delete all that. Let's do the 2.411. There it is. There's the intersection point between those two graphs. Right. And there was another one, I think it's 0.73? Yeah, like that. So that's a different kind of solution problem that you might run into is, you have to solve, you have a polar function and then you're asked to find the intersection with another equation or, line or something like that. This is R equals 2 is a circle. You could be asked to solve for an intersection with another equation. Let's just do another example here. So R squared equals 4 sine 3 theta. Let's do the symmetry tests. And let's do maxima. And let's do any zeros that we find. So yeah, before I start, I would look at it. R squared equals 4 sine 3 theta, because I don't have a sense off the top of my head of what that's going to look like. Okay, so R squared equals 4 sine 3 theta. Okay, doesn't like that. So we're going to have to switch over to better grapher. Switch over here. Not do that either. Let me see. Or we may have to do a positive version and a negative version. So we take the square root of that. That's a positive version. Subscript's going to be empty. Okay, take that out. So there's that one. And we're going to pair it with R equals minus. So this is the R squared. Putting those two together gives me the R squared equals 4 sine 3 theta. So it looks like I should expect in terms of symmetry, kind of symmetry in every direction, right? I mean, if I take a point here, I'm going to be able to find that same point over there. I'm going to be able to find it down here, and I'm going to be able to find it across the way over there. So I should be able to find symmetry in all four, but remember, in all three types, but remember that sometimes the algebraic part comes up inconclusive, so won't be shocked if it doesn't work out. And then I'm going to find maxima. Looks like I might have 6 maxima to expect. And then in terms of zeros, I should definitely have zeros because there's a bunch that are happening there. So we'll confine ourselves to, we'll set some parameters here. Let's say 0 to 2 pi. Let's start with the symmetry test. So theta replaced with negative theta, r squared equals 4 sine 3 negative theta. So that's going to, negative sign is going to pop out. We're going to have 4 sine 3 theta. So this is inconclusive. And remember that this is the vertical symmetry test. Second test, theta gets replaced with negative theta, and r gets replaced with negative r. That's horizontal symmetry. So minus r squared is going to give me 4 sine 3 times negative theta. Well, this cleans itself up, but again, I get the negative popping out here. So again, I have inconclusive. And last R, replace the negative R. That's the polar symmetry, rotational symmetry, and this one works out fine because sine 3 theta ends up being exactly the same. So we do expect there to be polar symmetry. And of course, we saw that there was vertical and horizontal symmetry, but the tests do not show that. So that's what you need to conclude from that. Okay, maxima. So when am I going to hit those maxima? Well, first I can tell that the maxima is 4. So when does R equals 2 is going to give me maximum 4 equals 4 sine 3 theta. So 1 equals sine 3 theta. When does that happen? It happens when 3 theta equals pi halves. Again, if we add on the 2 pi n, that kind of gives us the infinite solutions. And if we want to find from 0 to 2 pi, it's important that we can kind of track forward and think about when those next ones are, because of course, when we divide by 3, it shortens up the period. So this is the first solution would be, well, here I'll put them here, theta could be pi 6. It could be pi 6 plus 2 pi thirds. Pi 6 plus 2 pi thirds is pi 6. Do the fraction math yourself. And let's see, add another 2 pi thirds. 5 pi 6 plus 2 pi thirds. This is the next solution. So it's 9 pi 6. That's 3 pi halves. And I think the next one is going to be out of range. So if you take 3 pi halves and 2 pi thirds, yeah, because this is going to be 9, 6, and 4 6 is 13 6. So that just puts us slightly out of range. So those are the 3 maxima that we would expect to find inside 0 to 2 pi. Now it's true that when R equals -2, we also get a maxima. But I don't think that produces any new solutions for us. So I'm satisfied with these answers. All right, zeros. When do we get 0? Well, that's just setting R equal to 0. Okay, so we've got 0 equals 4 sine 3 theta. So basically, when does sine 3 theta equals 0, which happens in a couple of places. We got theta equals 0 plus 2 pi n. Actually, this happens every, well, right. And then we also have the pi version of that. So we could simplify this out by just saying, basically, any multiple of pi is going to give us a solution. And so that needs to be 3 theta equals pi n. So theta equals pi thirds n. So any multiple of pi third is going to give us a 0. So between 0 and 2 pi, we've got 0. Use a different color for my zeros here. 0, pi thirds, 2 pi thirds, pi, 4 pi thirds, 5 pi thirds, and last but not least, 6 pi thirds. So a bunch of zeros inside of that range of solutions. So anytime there's a multiplier in the sine or the cosine, that makes these types of problems a little harder because you have to think harder and push yourself to get more solutions, because that division by that coefficient is going to bring, the number of solutions up, in other words, because it's making the period shorter, so it makes the repetition happen faster. So you just see more solutions. Okay, so that's kind of polar coordinates in a nutshell. We looked at basic translation between coordinates. We looked at taking Cartesian equations and making them into polar functions, and we looked in this section heavily at polar functions and symmetry, and looking at also maxima and zeros and solution.